Hi guys, hi girls. So episode 2, yeah, of the eBay spares or repairs video cards. And those of you who watched the first half, you know I have 13 cards in total at the moment. So that's 10 off this one seller, which are listed here. And these, the starting bid was 100, and I was the only bidder. So £100 plus £9.50. And the ones with ticks are the ones that are actually here. The other 5 are still in the UK. And the reason being that the parcel went missing with Hermes for 8 days. You couldn't even track it. They'd lost it. And they even issued a claims notice, and then it turned up. By this time, my wife, who was still in the UK, I'd come back to the Canary Islands. She got so much stuff she was already bringing back, she just couldn't add much more weight to their luggage. So 5 of them got stuck in the UK. So I'll decide what to do with them. But anyway, yesterday we looked at that one, the GTX1070 3GB. Problem with VRAM. I did get the regulator to eventually start running the VRAM, and it blew one of the mosfets. But there's no shorts. All the resistances look okay on the various voltage rails. So I think hopefully, I mean I've ordered the parts, hopefully that's a repairable one, yeah. So this is the second one. It says Dual-X. So I haven't looked to see which one it is. If obviously one of the ones with the ticks on, yeah. This guy actually, this is how he listed. So gaming graphics cards times 10, all spares, repair, some display picture. On BIOS, no further test, yeah. And you notice here actually, he then goes to say all cards sale for parts, no return. Actually, this guy has been very canny about the way he's describing these items, because he's specifically saying that these are being sold for parts. He doesn't say they're being sold for repair or that they can be repaired. He says these are being sold for parts. So I'm sure if you then tried to claim these were not as described, it'd be very difficult to prove that there weren't any parts on that you couldn't be used. Yeah. So I think he's been very canny. The first one, somebody obviously, somebody's been at this before because it was sold a bridge, and it was obvious there'd been some work done on this before in the area where the fault actually was, but hopefully I will fix it. Anyway, waffle, enough, yeah. What's this one? Which one is it? E2437, oh, there's a sticker. This is probably the Radeon. Yeah, this is the HD7950. So it's this one, yeah. So let's have a look at this one. Let's see what condition it's in and whether it looks like somebody's been previously working on this one, yeah? Is this one of the ones that display a picture on the BIOS? Who knows? Okay, I will get this opened up and let's have a look inside it. Okay, so once again it was quite easy to open up. So just the 4 screws here, and we can now lift this off, yeah? As often, or normally always, held on by the fan. Okay, so all the pads are here, and 1 or 2 of them have remained sticking on the RAM. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 12 chips, and there were all the pads outside. As you couldn't see, I was just counting them. Yeah. White heatsink compound. This makes me think maybe this has been opened before. It's usually grey. I don't know whether that's any, if there's any truth in that really. Okay, so let's have a look at this card and let's see if we can see any visible damage. I'll get it under the microscope and have a quick look around it, and if I spot anything, I'll let you guys know. Actually, I know how much you guys love shouting at the screen, yeah. So let's do it together. So I'm going to look down the microscope, but I'm just having a quick look around here and see if I can spot anything obvious. I mean, it's a bit dusty, but that's nothing unusual. I don't think there's a problem. Is this? I'm just going to see if this is just. Yeah, it's just a bit dusty. Yeah, just a bit dusty. Okay, so looks like there's a fuse. I tend to do it like so, so I tend to go kind of like methodically up and down the board, yeah. Nothing much to see in this area. Look around the bottom. Okay, nothing really much to see here. Okay, let's have a look. So I'm guessing this just wasn't fitted originally, yeah. Okay, I don't see anything obvious on that side. Let's have a look at the other side. See if we can get any problems here. That looks like it's pretty well in focus for you guys. Let's have a look. If anybody sees anything, shout it out, yeah. I'm just having to just focus. My focus is slightly out, actually. Let me just get mine right, and then let's just get yours right again. One moment. Okay, let's just, yeah, that seems to be it. Okay, let's have a look. I don't see any signs of flux or anything that obviously somebody's been soldering or working on this. It looks fairly, you know, so far I say it looks untouched. I don't see any signs of previous work. Nothing. Oh, okay, what we got here. I was going to say nothing, and I'd say we've got something here that's broken on the board. Okay, as it's in your field of view. So here, that one, and that one. So we've got, that's a capacitor, and they're both capacitors. We've got two broken capacitors here. Okay. Another one here, yeah, which is a similar area, so it looks like any damage. You've got one there, one there, one there, so capacitor again. Just have to adjust the focus and moving further up the board, yeah. Again, I'll just get my glasses and just make sure you guys can see properly. Okay. Nothing particularly obvious here. Okay, so this does have three damaged components that we can see for certain, yeah. 1, 2, and the third one was somewhere, yeah, 3. Okay. These capacitors in this area, these are kind of under the RAM, yeah. So I think we can pretty much say, we can just check, but we're going to find that those capacitors are basically in parallel with all the other capacitors. And I don't actually think they would stop this from working. I mean, they won't change and they may affect the stability, but I don't believe they would actually stop this working. Okay, let's have a look to see what those capacitors are actually connected to. Okay, so if I just connect the black meter probe to ground, you'll hear it bleeping. I know you can't see it, but this end of this capacitor, in fact, you see the pads ripped off, but this is ground. This is ground. These are all ground this side. Now, if we go to the broken one, I'm sure this will be in parallel with these, yeah. So it's going to there, it's going to here. Yeah, I'm just checking the meter. It is reading 0. Okay. Yeah, 0. So those are all connected in parallel. Again, this is a ground point here. So yeah, one end of this one's ground. Yeah, one end of each of these is ground, yeah. And then the other end is connected in parallel with these. So these are all the same voltage rail, yeah. So yeah, so missing one isn't going to stop it from working. It wants replacing for stability. Is this on the same as well? No, actually that's on a different voltage rail. Is that across these ones? So we can find another. Okay, so this point, I just want to see if it's. on the same rail as, yeah, it's on that, same as that one. Same as that one, yeah, okay. So again, the missing one is just part, you know, on the same voltage rail. And the other end of these will be ground. Yeah. Okay, so from that we can say that these capacitors, although they're missing, are not going to cause a problem in as much as it wouldn't work. It'd be a case if I get a card working, you just want replacing. As to what the value is, I don't know, but I suspect that if we remove one of these, this will be the same as this one. Yeah. And the same with a small one. If we remove another one that's in parallel with, it'll be the same as that one. So by removing a couple of others, I mean, we might find a schematic if we're lucky, but otherwise just remove a couple of others and we'll soon figure out. And then I don't think it's anything like critical anyway, they're just decoupling capacitors. Yeah. Okay, so that's how to look at the physical condition. Now let's look at resistances. Yeah. If you've been watching my videos, this is becoming like a routine now, yeah, but that's good when things become like a routine, you know, you just go through the sequence, yeah, it's the normal thing. So, input voltages first, 12 volts, 12 volts, 12 volts and 3.3. So, first three fingers are 12 volts in, yeah. So look on the resistance range, let's see what we've got. So yeah, that's high, oh, sorry. I wonder what that is. It's my chin catching on the microphone. I'll put it a bit higher up to see if it was better. Okay, so that's fine. 3.3 is a fourth in. 1, 2, 3, 4. Yeah, put that where you want it. 1, 2, 3, 4. High resistance. And fifth one is ground. Normally. Sometimes it is ground. Yeah, just not got the bleeper on. Okay, so that's fine. Let's have a look at the ones over here. So, which side of the connector is it? This side is ground. So 12 volts coming in, it's fine, yeah. I was just accidentally catching the ground connections. They look okay. Another good place to check is on these inductors here. So one of these inductors will be connected to each of these. So these are on the 12 volts, yeah. So that's high point. It's like half a meg, almost a meg ohm on that one. Half a meg, a bit higher. So they're okay. This one is probably a 5 volt supply, or could be another one on the 12 volts. So that's reading high. That's okay. Then we have all the main phase of V core. These are probably all on the same phase, and probably as good a place to check as any, because these are like through all ones. I can turn it upside down, or I can just check on these capacitors here, which will all be on here. So this side's ground, yeah, and this side is V core. So V core about 4. That's just check another one, but random. That's fine, yeah. V core's about that, yeah. VRAM is probably this thing over here. So a little thing with a heat sink on over here is probably the control, and this is probably the coil. Again, it's a through hole one, but right next to it are some capacitors, and I'm guessing this is probably VRAM, maybe 50 or 60 ohms, 20. If that's VRAM, it's a little bit lower than I expected. Let's check on the coil, just to be sure. This coil here, yeah. So here's the coil. 20. That's a bit low. Whether it means there's a problem with the VRAM, I'm not sure at this moment in time. But that is reading a bit low, yeah. Okay. Some inductors on the back of this one, so we'll check these. 285, okay. This one, this 156. This is probably PEX just because of where it is, the 0.9 volt. This one, I'm not sure, it could be for the memory controller, maybe. And that's about it, really. We could have some LDOs. There's going to be a 1.8 volt regulator somewhere, yeah. The big looking resistors probably act like fuses, so just check these. So these should be actually read short or close to it, yeah. That's reading 10. I'll have to check the value of that No, that looks like it should be a 1R00. Let's just zoom down on it. Okay, so this looks like a low value resistor, 1R00. This rail to ground is reading about, it's quite high. Yeah. What's the thing itself reading? 1.3. Okay, so that's close enough. I probably didn't have a good connection before. This might be another one here, this funny looking thing here could well be. Yeah, that's fine. This is probably a voltage regulator. It could be the 1.8. It could be a 5. Yeah, just trying to guess. Couple more low value resistors down here. These should read like 0. So 0, 0. Yeah. Okay. So there's no obvious shorts on this one. Another one of these fuse-like things up here. So we'll check that one. Yeah, practically 0. I'm not sure if they are fuses, just sort of they look like fuses to me, yeah? Okay, so everything looks kind of okay on here, apart from maybe the RAM is reading quite low. Let's see what brand the RAM is. I know Samsung reads lower than others. What brand of RAM do we actually have on this one? Just shine a light on it, shine a bit of light on it. One there. Can't easily see what it is. I'm just getting a microscope. Just one moment. I'll tell you guys what brand of RAM we have on this. It's ELPIDA, ELPIDA, whatever that is. ELPIDA is what it says on it. Not one I'm particularly familiar with. So yeah, maybe that the RAM reads like about 20 on this. It's hard to tell. It could be that reading 20 is maybe that the memory controller, and the other one I found is maybe the RAM reading 130. I don't know this card, basically. So there's always some could be's, yeah. But I think the thing was to do with this one now is to plug it in, and let's see what it does. Let's see what voltages we have on it. Right, we're good to go. So everything's connected up. The first thing I'm going to do is measure the V core, just to make sure if that's there, we know we need to put some sort of cooling on this, yeah. So let's just start the PC and let's see what actually happens. Well, the PC starts up. What we got on the V core will be on these little capacitors here. Just slipped off the ground screw again. Nothing there. Okay, so we got V core. It's getting a little bit warm, it's not hot. So we've got V core. I'll just find it again. 0.9 of a volt. What's on these? These would be 12, I would think. 12, 12, 12. I'll just give this a little bit of cooling. This is just like a thermal pad, a chunky thing I just sort of stick on. I can always rest the heatsink on top of that. It just gives a little bit of thermal mass and just keeps it cool a little bit longer. It wasn't getting particularly hot anyway. I just, like to make sure they've got at least something just to cool them a little bit. So again, we'll start the computer. Assuming because V core's up that all the rest of them are up, because that's the last voltage row that will come on an AMD card. So what do we have here? Yeah, 0.8 something. This could be the memory controller because it's very similar to the V core, yeah, 0.9 something. So VRAM on this one is where? Probably one of the ones on the other side of the board. Let's just arrange it so we can get at them. So I flicked it the other way up. But VRAM is maybe on one of these two. I'll have what this is possibly PEX. I'm not sure what this one is. Looks like the one with the big coil is the memory controller. It's reading too low for VRAM, unless there's a problem there. Otherwise, we can check on some of the capacitors that are near the RAM. That will give us a good reading. So again, we'll start the board up. Let's have a look what we have on this side. So yeah, this is PEX 0.962. 1.78. That's a 1.8 volt regulator. Yeah. What's on? What's on the RAM? Oh, these capacitors. 0.3134. Okay. From what I can see so far, this board doesn't seem to have a VRAM. Yeah. VRAM seems to be missing. I've got 0.134 on a lot of these capacitors. So what I need to do now is figure out where that VRAM supply actually comes from. The interesting thing is that VRAM is there and VCore isn't, because, sorry, VCore is, because on these sort of cards, I would have thought that VCore only comes up after VRAM, and there's an enable coming from the VRAM regulator, which effectively generates the signal to turn on the VCore. Like a power good comes out of the VRAM, and that goes to enable on the VCore, yeah? Well, VCore is obviously enabled. Okay, let's have a quick look and find out where the VRAM supply actually is. Okay, I got it. It was quite easy, really. So, just looking straight away, there's a VRM here. I'll zoom down and you'll be able to see it properly. Okay, let's just set a bit of focus on that for you. There you go. Right. So, what you'll see here is we have 5 phases, yeah, the count the coils 1, 2, 3, 4, 5, because that one isn't fitted, the 6, yeah. We have 5 phases, and this one is clearly separate, yeah. This is the capacitors under the RAM. Now, if you look at some of these big capacitors I was mentioning, I measure across them, I read about 60 ohms, which is what you'd expect for VRAM, yeah. The one that was reading 20 something is the memory controller for sure, and the voltage on it was pretty much the same as the VCore, which also tells you that is the memory controller. So the capacitors are also here, yeah, and this coil here, just off the shot, so you can also see the 60 across here, yeah. Just get onto them a bit better than that. Yeah, there, yeah. 60 ohms to ground, exactly, yeah. So this coil here is the supply for VRAM, okay. And it's not running well. We've got about 0.13 of a volt on it, which is not right, yeah. So what we need to do now is have a look to see where is the controller for this. I suspect it's probably, there's a 6-phase controller somewhere, and it's kind of like 6 plus 0 or 5 plus 1. It can be used in different configurations. So let's have a look to see if we can find that, yeah. Now we can see quite clearly. So these 5 are actually on one phase. Now look, there's even a bigger gap there to that one, yeah. These 2 capacitors, oh, sorry, that's a bit of the door. These 2 capacitors, this coil, are generating the memory phase, and then these 5, and if you look, 7 capacitors, yeah, are all on the main VCore. Yeah. So the chances are highly likely that this is the controller chip, yeah, that's controlling all of them. And I suspect this has got a problem, or there's a problem maybe with the MOSFETs, which are under here driving this. So let's get this piece of heatsink off here, and let's have a look at the part number of this chip to see if this is the one that we want to be, see if we've had a data sheet for, yeah. Okay, so the heatsink's off now. You can quite clearly see now these 5 phases have like this kind of like driver come MOSFET all in one chips, yeah. And there's 2 MOSFETs here. These look like the last board if you looked at the other board, but the other board on the memory phase we had 2 coils, so each one was a dual MOSFET. In this case there's just 1 buck regulator coil, yeah, a couple of electrolytics and some more capacitors all over the place. So these will be single MOSFETs, yeah, driving this coil. I'll draw it for you in a minute. I haven't done that for a while. Okay, and then this is what we are thinking is a controller chip. So let's see what the microscope tells us about the part numbers. So this is the chip I'm interested in. This is on semiconductor NCP 4206, yeah. Now it's possible that is also driving the memory phase. We need to figure out if that is the case, yeah. So these MOSFETs, the 2 of them here, are 4C05N. So we can find a data sheet for them, and we'll try and find a data sheet for the other chip, yeah. If this turns out it can't drive all of these, then we'll have to look elsewhere. In fact, I'll have a quick look now. But if this isn't driving all, we need to find the controller that is driving these, yeah? Which could be on the other side of the board, to be quite honest. If we can't find a datasheet, then we can measure from the gate of these back to any pin on this chip. If they come back to here, this is what's driving them, yeah? While we're at it, let's have a quick look on the other side of the board. Okay, so this is the area underneath the memory phase. I don't see anything here. There is what looks like could be a controller here. Yeah, what's this device? So we get some focus on it. There we go. So this device, 5230 RXD. So it's possible that is driving the memory phase. Again, if we measure from the gates, we'll know, but we'll try and find a data sheet for this thing as well. Well, that looks more like an SMD code. Otherwise, in the back of here, I don't see anything else. These are all transistors, which are part of the power on logic, yeah. There's one other factor that makes me suspect that this chip is driving all 5+1 phases, and that is the fact that both power rails are coming up, and normally if the VRAM is on a separate controller and it's not coming up, you wouldn't get a power good to enable the V core, yeah. In this case, although VRAM is wrong, we do have it enabled, and that makes me think maybe it's all in here. Alright, let's have a look on the internet, see what we can find. Okay, I actually found some data sheets for both of the chips this time, so that was quite handy. So let's have a look to see what we've got here. So this is the NCP4206, and it is a 6-phase controller, yeah, multiple phase controller, and it measures 1, 2, 3, 4, 5 or 6 phase operation, and we have 5 phases. But this is for like a single regulator. It won't run like in 5+1 or 4+2 that will be mentioned here, yeah. So it supplies one voltage rail, okay. So that is not where the supply to the RAM is coming from. It's coming from somewhere else. And the other most likely place it's going to be coming from is that other chip on the other side. It's marked 5230 data sheet. And I actually found this one via browser. There we go. So again, NCP, another on semiconductor. And this one is a single phase. So this is the one that's driving the 2 MOSFETs that's generating the supply, yeah, for the VRAM. I said I'd draw it for you later, but you can actually see it here. I don't need to. So these are your 2 MOSFETs, high side and low side. So you have 12 volts coming in here, the high side MOSFET going to the coil, yeah, and also from here the second MOSFET going to ground. So these switch on alternately, first this one, then this one, and backwards and forwards. And that's what pumps effectively power through here and generates the output voltage. And the output voltage will depend on the ratio of the amount of time that this one is on compared with this one. So if this one on is for longer, if it's on, so if this one is on for longer, then you get more voltage out here, yeah? If it's on for less time, you'll get lower voltage. So that's basically how this works. So we need to have a look at this chip. The pins I'm interested in are going to be the power pins and the enable pin, yeah? So we have VCCP, which looks like it should be a power pin, and also VCC. So it looks like there's 2 powers here. This is quite common. If you saw the previous video, we had the same setup where we had effectively a 5 volt supply and a 12 volt supply, and then a 3 volts enable. Does this have an enable pin? It's not called EN if it does, but we can have a look. So let's just zoom it down a little bit. So this effectively will explain somewhere be a pin out for this, I would think. It's normal that there is, yeah, I'm not saying there is. A list of the various pins. Let's see. Is it further up? No, funnily enough, it doesn't actually tell you what these pins are. That's very bit unusual, that is. Yeah, shows you. But, oh, yes, it does. Here we go. So, VCCP, power supply for bottom gate MOSFET driver. That's one power supply. Yeah, VCC is the other one. the supply rail for the controller internal circuitry. Is there an enable pin? Just looking down all these various... There's a power good, but that's an output coming back out that says effectively the rail is up, yeah? No, it's nothing to do with that one. These are all voltage sense pins, current sensing the inductor pins. No, so basically this is showing really that if we've got VCCP and we've got VCC, it should work, yeah? Is there any information that suggests what these voltages should be? Telling you there's the output voltage between 0.8 and 3.3, which is great, yeah? Input could be between 1.5 and 19. Often there'll be, fairly typical application, which doesn't tell you the voltages. Let's have it to see quickly. Electrical characteristics. I may have missed it, but same as having a good... I mean, we could look through here, we could eventually probably look up the correct voltages, but what we can do is measure the voltage on ours and see what's going on with it. So I'll just make a note of the various pins that we're interested in. Okay, it does. I just had a little bit of time to read the data sheet a bit now. So, here, pin 14 is an enable pin, yeah? This one. Programs the switching frequency, pull low to disable. So if pin 14 is low, it is disabled, yeah? 15 is VCC and 1 is VCCP. I'm guessing one of these is probably 5 and the other one is probably 12. It does say that there can be any voltage up to 17. It's in the data sheet, it mentioned the maximum voltage. So we're interested in pin 1, which should be a voltage supply, pin 15 should be a voltage supply, and pin 14 must not be low. Okay, let's see what we've got. I'm sure you probably noticed if you watched the previous video, I like to try and avoid probing directly on these chips if I can, because they're so small, it's so easy to slip, and being in VRAM you might not know exactly what it might do if you do short two pins together. So what I like to do is try and find nearby components going to the pins that I want that are easier to actually get a probe onto, yeah? So I'm going to show you the microscope at the minute, but you'll see 3 components here. This is a capacitor, and this is VCCP going to pin 1. There's a larger component here, a capacitor going to pin 15 and 1 to 14. So we've got VCCP, VCC, enable. I'm guessing 12 volts, 5 volts, and 3.3. Okay, let's have a look at what we've actually got on ours. And of course, you'll notice the qualifying word there, guessing, yeah, because in a lot of cases with this, you are guessing. Okay, so we have power on. We can start the computer. Now let's see what voltage we've actually got on our board. So computer's on. So find a good ground first. Ground. This makes it easy then. So the first one is on here, yeah, and this is reading 12 volts, yeah, VCCP. This is VCC on this one, yeah, and that's reading 5, yeah. And then the enable is on this one here, and I'll just use the microscope. Just get down here. Oops, sorry, it's probably sliding a little bit. It's there, yeah. What's that reading? And you guys tell me, without my glasses, I can't see the. When I come off the microscope, I can't see the meter. Yeah. Let's just do it this way. 1 moment. Okay, 1.2 volts. I'm not sure that's enough. What's the other side of it? What's the other side of this resistor? Nothing. It's going down. 1.2. Definitely 1.2. Nothing. Well, that's strange because it's an input. Okay, so we've got something definitely odd going on there. I'll just switch it off now before it gets too warm on the GPU. Yeah, it's not particularly warm. That's interesting. So there seems to be a problem with the enable to this chip. Yeah, 1.2 on here. What value is this resistor? have a look. So I've switched it off now. Measure across this resistor. 26.82 kilo. That's quite high. I mean, I don't know what it should be, but that seems a little bit high to me for an enable signal. I mean, maybe it is. Okay, let's see, find out where this comes from. The first thing I'm going to do now is see if I can actually possibly find the schematic for it, yeah? Okay, I don't have a schematic for this type of card. But what I did just do now again was just to refer back to the data sheet. I mean, this has got like 1.2 volts on this side of it, yeah, on one side of it. But like nothing on the other side of it. Now, first thing that should tell you straight away. Let me just show you what I mean. Let's just yeah, this thing. So the side nearest the chip on this enable pin has got a 1.24, wasn't it, I believe. And the other side of this resistor has actually got nothing on it. So wherever this voltage here is coming from, it can't be coming from here, yeah, because there's no voltage on the other side. Well, it's not an output, it's an input. So that either tells me that this is also connected to somewhere else, and that's where the voltage is coming from, or the voltage is being generated internally on this chip. Okay, so I then had a look, I'll show you now, I had a look at the data sheet just to see if I could find any more information out regarding that, yeah? So I'll show you what the data sheet actually says. So here we go. And you can see here, this ROSC-EN, it then says 1.24 volts. And this is on the inside of the box. In other words, I'm sure this is saying this is an internal voltage supply, and I'm sure that's exactly what we've seen on that pin there. So that tells us that the voltages are actually correct, but this chip isn't working properly. So it could be there's a problem with the MOSFETs it's driving. It'd be interesting to see what's coming out of this chip now, lower gate and upper gate, and probably to do this we need an oscilloscope. So pin 5 is upper gate and pin 2 is lower gate. Let's have a look at that and see what we've got coming out of it. Okay, so pins 2 and pins 5 of this chip drive the MOSFETs, yeah? I won't just use this oscilloscope, I will actually have a look just to see where they go. So pins 1's by the dot, so anti-clockwise, so pin 2 is here. And I think you can see it goes to this thick trace, and pin 5 goes to this thick trace. So 5 is easy to get onto, pin 5, and this goes, it goes to here, yeah, that goes to there. Pin 2, 1, 2, this goes to the other one, I think, yeah. So both of those outputs go to those two resistors up there. I can see one of them is a 1 ohm resistor, yeah, and the other one isn't marked, but I imagine it's probably the same value. So yeah, these resistors. The other end I'm guessing goes to the gate. Okay, yeah, here. What's it reading? And I'll just get the phone, I'm sure that is a 1 ohm resistor. Yeah, you see 1 or 0, yeah. It's reading open circuit. This one. Yeah, that's reading practically short. So it looks like this resistor here, which has one of the gate signals on, is open circuit. It is, isn't it? I mean, I'm definitely connected on that, and that's definitely open circuit. And this one is okay. Okay, so we need to change this 1 ohm resistor. It's obviously reading open circuit. If we've only got drive to one of the two MOSFETs, that would explain why the voltage rail is low. If anything's coming out, you probably just get a bit of voltage coming off it. Okay, so we might have found that. We actually might have found a problem there. Okay, so there's our resistor replaced there, yeah, in the centre of the field now, another 0 ohm resistor. So we can just check this now. I'm sure this is now okay. Yeah, read 0 as expected. This one was reading 0. Okay, so let's power this card back up and let's now see if we've got VRAM. And if we have, let's see if it actually works. Okay, so we're about ready to go. I don't need to flick this upside down now to find VRAM. We know where it is because this phase is separate from the others, yeah? We know the RAM has a 60 ohm resistance, so if we check on these capacitors here, if they read 60 ohms to ground, so one side will be ground, yeah, there, 60 ohms, and the other side ground. So we know, because the 60 ohms, that this is VRAM anyway, yeah? So what we can do is now, we can actually power this back up again, and have a look to see if it now actually gives us the voltage we want. I mean, I've even plugged the monitor in. You never know, it might even work now, yeah. So that's on there. So we start our PC once again. Oh, hold on. I've missed off some wires. One moment. I'd forgotten to connect the power supply back to the motherboard. It was connected to the video card. So yeah, let's switch it on. Yeah, power's on. Power on. Ready to go. Let's see, should the PC start up again? Yeah, PC started. What have we got now? Voltage range. No, it's still low. That's amazing. I mean, sometimes I'm so unlucky with these things, but never mind, we can continue. That's surprising that actually didn't start that. Let's check those resistors that we replaced, see if they actually do go to these. Yeah, I'm pretty sure that's where they were going to the gates of the MOSFETs. Okay guys, I've sussed it. You've probably been shouting at the screen all the time, yeah. I followed the gate of one of these back to those resistors where I just replaced that resistor, yeah, and I got a connection, and then I followed the gate of the other one and it didn't go to the other resistor, so this one went to the original resistor, yeah, and I thought, well, this one must go to the replacement resistor, and it didn't. Okay, so I had a look where the other resistor actually goes to, and it goes to a via, and the via actually comes to here, and this is the high side MOSFET that somebody's taken off the board. So once again, somebody's been messing, yeah. But I strongly suspect the problem is what I fixed, that is the 1 ohm resistor that was open circuit, and somebody thought this MOSFET was faulty, possibly changed it, made no difference. It would make sense that if you've only got drive to the low side and not the MOSFET, you probably get a little bit of voltage out of the damn thing, but not much, yeah. Although I'm not totally sure how you get a bit of voltage, but there you go. So what it seems to have here is the fact we have a missing MOSFET, and the gate pin, which you can clearly see is here, actually goes to that other resistor, the one that I've just fitted. I mean, to be fair, I should have suspected this originally. Yeah, I mean, it's quite often to have one high side and two low side. It's not that unusual. But if I had have suspected this originally and changed it, it probably wouldn't have worked. It may have taken me longer to find out what the actual cause of the fault was, because I'm pretty sure that's what was the cause. Okay, so let me go and find out what MOSFET is supposed to fit on here, yeah? And then let's see if we've got something suitable here, otherwise I'll have to order some parts for this one as well. Okay guys, so I asked on Badcap's forum about the missing MOSFET, and it turns out this is actually the part number. You probably just recognise as being a 4C1010. That'll be that's what's marked on the actual MOSFET, and one of the guys on there actually found a couple of high-res photos of basically this sort of card, and we could see what the part was. So that's how that was worked out. This is the controller chip. So I've ordered some of the MOSFETs, I don't have any, and while I'm at it, I've ordered some of these controller chips as well. And the reason being, I'll just have a quick chat with you about this. So this is the resistor that I changed, and I actually put a 0 ohm in here. Now initially this had a 1 ohm resistor in. You might wonder why I put the 0 ohm in, and there's a couple of reasons for that. Well, there's three really. first one is that the other resistor next to it actually measures 0, and that goes to the gate of the low side MOSFETs, and this goes to the high side MOSFETs. Yeah. The second reason is this resistor was actually marked, 1 or 0. If you look at this graphics card, I don't see any other resistors anywhere on the card that are actually marked. They're like the one next to it, there's no marking on the resistor itself. And it seems strange to me that this resistor would actually have a marking on it, when none of the other ones have any markings anywhere. Yeah, if we just have a look around on the board, if we find some resistors. Okay, some there, the bigger ones do, these 0 ohms, fair enough. But the small ones, they all don't. And because of the problem in this area, I'm wondering if somebody's changed that. It didn't particularly look like they had. But the third reason is that these are connecting to the gate. Now, the whole point of a gate of a MOSFET is effectively it's an open circuit. You put voltage on the gate and the MOSFET turns on. But there's effectively no gate current. It's not like a bipolar transistor where you have a base current, an emitter current. There is no gate current. So I don't honestly see why 0 or 1 would make the slightest difference. Yeah. But I can put 1 ohm resistor in just to make it the same as it was before, not a problem. Right, the other quick thing then. So this missing MOSFET, I mean, I'm sure most of you know how this is wired up, and I did mention it, but let me just show you for those of you, obviously, you beginners on here. Let's see if you can if you didn't quite get it, I'll explain it to you now. So basically, this is a buck regulator circuit. So you have a controller, yeah. Control, okay, a chip. That's in our case of this one, yeah. And this drives 2 MOSFETs. So the first one will go to the 12 volts, yeah. And it comes down here to the second one, yeah. The second one, the visual is a bit messed up, never mind, yeah. Goes down to ground, okay, and that's your 2 MOSFETs in series. And this point here goes to the coil, yeah, capacitor or capacitors, and then the load. Yeah. So 12 volts comes in on the first MOSFET, and the other one connects the coil to ground. And these switch on and off alternately. And this is called the high side, and this is called the low side. Or high side MOSFET, low side. And the reason this is high side is because the high voltage, the 12 volts, is on that one. And this one connects to the ground. This is why this is the low voltage side. So high voltage side, low voltage side. High side, low side. Yeah, that's what we call them. So usually this signal here is called HG and LG, high gate and low gate, yeah? And that's what we have. Now, in our circuit, and in a lot of cases, we have this. From here, yeah, is another MOSFET in parallel with the first one, yeah, like so. And these 2 MOSFETs together form the low side, so effectively they both turn on at the same time. So the gate of this one, yeah, goes to here, yeah, and these 2 effectively share the load, so you have 1 in the high side and 2 in the low side, and this is very, very common, yeah. So in our case, both these were present and this one was missing, yeah. So these 2 are the low side and this is the high side and this is the missing one. I mistakenly thought there was just 1 high side and 1 low side, so you can have that, yeah. So these 2 resistors were here, okay. 1 there and 1 there, yeah. And this one measures 0 ohms, 0 R, yeah. And this one was marked 1 or 0, which is 1 ohm, but it read open circuit, yeah. So I now have put another 0 in here, yeah. As I say, because it only supplies the gate, there's no gate current, I don't see it actually makes a difference, but that's what I have done. And if you guys feel better about it, I'll put a 1 ohm in there. Just let me know what you think. I'll happily do it. Yeah. So that's what we've got. Now, clearly, somebody's been working on this graphics card before, and actually, I mean, we've looked at 2 of them so far out of the 13, and in both cases, somebody had been working on before. One had flux on it and had a solder bridge, yeah, and this one, this has been removed. So they've definitely both been looked at before. So if that's an interesting fact, I don't know. I don't know why this resistor is open circuit. Was that the original problem? And that was the original resistor. I mean, it didn't look like it had been soldered, to be honest. And therefore, somebody didn't find the fault and thought it was this and it's been removed. And this tested okay. And then he thought, oh, shit, what's wrong with this? I don't know. Yeah? That's one possibility. The other possibility is this has been gone open circuit because of some sort of failure with this device, sent voltage down here and into the controller and possibly internally shorted this output. I haven't checked it, you know. So because I don't know the situation that's arisen to cause, you know, we know what the evidence is, but we don't really know what the situation was, yeah. So because of that, I've ordered some of these, 10 of these, I've ordered 10 of these. The reason I've ordered 10 is because these were about €3.50 and these were about €2.50, yeah, for 10. You might as well. These ones, if you look on AliExpress, I can see like, you know, 33 or 40 or 50 feedback, and people say they're good, and quite a lot of these. The fact is a lot of these have been sold makes me suspect as they fail often, yeah. I think you can possibly take that as some sort of evidence. If something is selling, then it's something that's failing, yeah. Okay, guys, so that's it. Can't do any more with this one now, but we'll load the video up, and we still have quite a few more here we can look at. So I suspect these parts will be here back end of the year, maybe early January. We'll see what the post's like now, and let's get on to the next one. All right, guys, so hope you enjoyed that. Sorry, another failure, but I'm not quite sure we called it a failure. I think we've got a very good idea what's wrong with this graphics card, yeah. Okay, guys, have fun. See you all soon. Ciao for now.